had finished the Newton's second law of motion, but I brought like two kind of exercises from your NCERT textbook to make us more familiar with the application of Newton's second law of motion. So let us go for it. Look at the first equation of question over here. Which would require a greater force accelerating a 2 kg mass at 5 meter per second square or a 4 kg mass at 2 meter per second square? I will solve this problem over here, right? Okay, this is the solution. So now, according to Newton's second law of motion, we know that force is equal to mass into acceleration, right? We knew this, right? So now, in this particular thing over here, this question, they have given you two different kind of situation here. Situation number 1 and situation number 2. 1 and 2. In situation number 1, which would require a greater force, that means you have to calculate the situation number 1 and 2, in which case the force you have to apply more amount of force. Now let's have a look. Situation number 1, accelerating a 2 kg mass. They have given you mass is equal to 2 kg in situation number 1 at 5 meter per second square. That means meter per second square is always the unit of acceleration. So we are going to take acceleration as 5 meter per second square, right? Okay, now if you look at the situation number 2, or 4 kg mass at 2 meter per second square, that is, you are going to write mass as 4 kg at an acceleration of, how much is that? 2 meter per second square. 2 meter per second square. Now this, you have to use this simple formula over here, that is force is equal to mass into acceleration. How much is that? Mass is 2 and acceleration is 5, which is equal to 10 Newton. That's your answer here, force. And second one over here, force is equal to m into a. How much is m? 4 into 2 is equal to 8 Newton. Now which one is more, 10 Newton or 8 Newton? 10 Newton is more. So what we are going to do, in this case here, this particular situation here, 2 kg mass require at 5 meter per second square require greater force of 10 Newton. If you compare situation number 1 and 2, in the one case we need more amount of force to do that, right? Okay, so now let's go for the second one here. Now, in the second situation over here, a motor car is moving with a velocity of 108 km per hour. So let us do it over here. This is the solution here. Now, we know that force is equal to, again, mass into acceleration, right? Okay. So, now what they have given, a motor car is moving with a velocity of 108 km per hour and it takes 4 seconds to stop after the brakes are applied. That means this particular car is moving at a velocity of 108 km. Suddenly they applied the brake and it took 4 seconds for this motor car to stop. So what happened now? Now we are going to write the given part here. What they have given. There are two types of velocity. Velocity number 1 is initial velocity and second one is final velocity. Now what is the final velocity? Final velocity means when they apply the brake, the motor car is going to stop. That means velocity is 0. That is, the final velocity is 0 meter per second. Now what is that velocity? 108 km per hour. That 108 km per hour is the initial velocity and we got the time as 4 seconds here. Now let us do it. Calculate the force. Again we have to calculate this one here. Calculate the force exerted by the brakes on the motor car if its mass along with the passenger is 1000 kg. So they have given you the mass as 1000 kg over here. Is that clear? Now all this thing looks quite cool except this part here. 108 km per hour. We have to convert this into meter per second. So that's quite simple. We are going to do that. U is equal to 108 km per hour. I told you before in the chapter of motion, whenever we are going to convert kilometer per hour into meter per second, you have to multiply by 1000 and divide by 3600 here. 108. Why? Because in 1 kilometer there are 1000 meters. Divided by, in 1 hour there are 3600 seconds. So now you can cancel it, right? And 36 ones are 36, 36 threes are 108. So 3 tens are 30, that is 30 meter per second. Now this is what we got now here. U is 30 meter per second. Now let us go for it. I'm going to rub this card. Okay, so I'm going to copy the equation here. That is, this is not the party. Okay, force is equal to mass into acceleration. We knew the mass, but acceleration is equal to, what is the formula for acceleration? Is V minus U upon T. That means acceleration means change in the velocity with time. Change in the velocity with time. So, now how much is the mass? Is 1000 kg. 1000 into, how much is the final velocity? Look at the final velocity. What is the final velocity? 0. Minus, what is the initial velocity? Initial velocity is 108 kilometer per hour, which we changed it. When we convert this kilometer per hour into meter per second, we got 30 meter per second. That means we got 30 meter per second in a time interval of 4 seconds here. 4. Understand? Now we have to cancel this, right? Let's see, I'll do it in a very simple way. 4 and 500 and 2 ones are 2 and 250s, right? So what we are going to get? 250 into this into. There's an into here. 0 minus 30 is minus 30. Right? Okay. Now when you multiply this two, what you will get? Minus 7500 Newton. Now look here. Our answer is coming in minus here. Why? Now look here. Calculate the force exerted by the brakes on the motor car. That means you will have to understand the question. In this case here, a motor car is moving at a very high velocity and suddenly brakes were applied. And what is happening to that motor car? Because of the brake, application of the brakes, his answers, that is the -1. Because whenever we are not accelerating, when we were accelerating, our value, our force value is going to come in positive way. But whenever we are applying brakes, the acceleration is always going to get reduced. When the acceleration gets reduced, our force is always going to come in negative way. Is that clear? So this is about the application of Newton's second law of motion. Now we will proceed for the next one, that is Newton's third law of motion. Okay, so Newton's third law of motion. Okay, now in this Newton's third law of motion, first I will create a situation over here. Number 1, this is a ground. On this ground, there is a presence of a ball. Okay, right? Now this ball, if you look at this particular ball, is it experiencing some amount of force? Yes. Force number 1, that is gravitational force. Right? Gravitational force. Gravitational force. Now, if this particular ball has the presence of only gravitational force, the direction of the gravitational force is always downward, so we should be expecting that this particular ball will move down, or maybe in the form of slope, it will move down into the soil. That means gravitational force is acting always downward, right? But there is another kind of force exerted by the ground itself. This is what we used to call as the normal force, or the force of reaction. Force of reaction. Now we know that even if we apply a small amount of force on this side, this ball is going to move. That means this ball is neither moving inside, neither going outside. Why? Now, when we think about that, the force of reaction here, this is the force of reaction, and this is the gravitational force. Both of them, as you can see, this is acting downward, this is acting upward. Are they in opposite direction there? That is the first thing in the case of Newton's third law, that two forces are going to act in opposite direction there. Understand? Now, secondly, we know that if the gravitational force is small, then this particular ball is going to move downward. But we didn't see anything like that. And if this particular force is small, then this is going to move up a little. Even in this case also, we didn't see something like this. But why this is not happening? Because this particular force and this particular force are equal in magnitude. That means, let's imagine if this is like 4 Newton here, and this is also 4 Newton, which they are going to cancel out because they are in opposite direction there. Understand? Now, in the second kind of situation over here, okay, so there is a person again. He was on a board and he was reaching the shore, seashore part. Now he wanted to jump onto this side here. Understand? Jump onto this side. Now, if this particular person applies a little amount of jump, then this board will move a little bit backward. Is that clear? If he is going to use all his energy to move and jump with a more amount of force, that means, let's say, if he is applying a more amount of force, let's say like 40 Newton, and this is also going to move back a lot, right? In the case of 40 Newton over here. Now, as you can see, this and that, they are in opposite direction there. Is that clear? And this 40 Newton and this 40 Newton, they are also equal in magnitude. So, according to Newton's third law, there are two things here. Every action here, what they have written, okay, every action has equal and opposite reaction. Now here, in this case here, this gravitational force, this force is referred to as the force of action here, action, and this is referred to as the force of reaction. Every action has equal and opposite reaction. That is the reaction here. In this case here, this is the action part, and this is the reaction part. Okay, so generally when we talk about Newton's third law, there are two things that is important for you to keep in your mind. Number one is the magnitude here. Number one is magnitude, and this magnitude should be equal. This magnitude and that magnitude should be equal. If this is 4 Newton, this should be 4 Newton. If this is 5 Newton, this is 5 Newton. And the second one, is action and reaction is always opposite by nature. So if you keep these 2 points in your mind, you have somehow understood the Newton's third law of motion. So tomorrow we will practice the law of conservation of mass, which is also related with this particular law, that is Newton's third law of motion. So we shall go for the next one in the next class. Thank you very much for listening very well. Thank you everyone.